What is the observable universe exactly? The term observable universe refers to the area of the universe that we can view and study with telescopes and other tools, but this ability is constrained because light, which is the primary source of information about the universe, can only move at a finite speed. As a result, we can only see objects or events that are a specific distance away from us. We are unable to directly see objects or events that took place a long time ago. The observable universe's diameter is estimated to be around 93 billion light-years, which is significantly greater than the universe's approximate age of 13.8 billion years. The reason for this disparity is because once-close objects have moved apart due to the universe's expansion, making it take longer for light from those objects to reach us. Overall, the observable universe is a huge and fascinating space, but we still don't know much about it. Nevertheless, with the help of telescopes like NASA's James Webb Space Telescope and other scientific instruments, we are learning more about the structure, composition, history, and various phenomena of the universe. Join us as we discover the NASA structure that the James Webb Space Telescope recently made contact with in the far reaches of the observable universe. If you want to stay up to date on news from the universe and its environs, please subscribe to our channel, like this video, and click the notification bell. We would need to create means of transportation that would enable us to transcend spacetime, such as wormholes or distortion engines, in order to reach the outer ends of the visible universe. The feasibility of both faster-than-light travel and the use of advanced technology beyond the reach of current human intelligence is a topic of intense debate among scientists. Even if it were theoretically possible, it would require technological advancements and machinery that are currently beyond our capabilities. These concepts have long been the subject of debate among scientists, some of whom believe that they are simply impossible or that they contradict the idea of faster-than-light speed travel. Since we cannot see or measure the unobservable part of the universe, we have no way of knowing with certainty what lies beyond its limits. Nevertheless, this does not mean that we cannot develop theories based on the information we have gathered from distant galaxies, and NASA plays a significant role in this process. According to the theory of cosmic inflation, the total size of the universe is at least 10 to the power of 23 times larger than the observable universe. Even before the James Webb Space Telescope went into service this year, NASA, working with other space agencies and scientific institutes worldwide, has made a number of important advances to our knowledge of the cosmos. NASA had already released images of the ultra-deep field obtained with the Hubble Space Telescope. However, when the James Webb Space Telescope made its debut, it was taken out to observe the most distant galaxy ever recorded. These images revealed the presence of numerous galaxies shining in the distant cosmos, apparently as they were millions of years after the Big Bang occurred approximately 13.8 billion years ago. The expansion of the cosmos causes the stretching of light to redder wavelengths, which allows the James Webb Space Telescope to detect infrared light. This has allowed us to observe galaxies forming in the early stages of the universe's history. The James Webb Space Telescope has made observations of several fields of distant galaxies, allowing scientists to study the rate at which stars formed in the early universe. This data revealed the existence of a significant population of galaxies that were forming stars in the early stages of the universe. These discoveries are truly fascinating and thought-provoking. For a long time, humans have considered the possibility that we are not alone in this vast universe, but these recent discoveries in the observable universe have led us to conclude that the unobservable portion of the universe must contain millions of galaxies. This is a startling idea that inspires awe and wonder about the size of the cosmos and whether there are extraterrestrial beings somewhere in it. We are considering the potential of alien life because the evidence for life beyond Earth has never been stronger. There are numerous planets outside our solar system known as exoplanets which have been discovered using techniques such as the transit method and the radio method. Some of these exoplanets may have similar characteristics to Earth and may harbor life. This theory has been supported by another discovery made thanks to the James Webb Telescope related to the exoplanet WSP-96b. This planet is outside our solar system, and its light spectrum reveals something surprising: the presence of water molecules. In addition, the spectrum also shows hints of haze and clouds which were not previously thought to exist on a habitable planet based on the habitable environments found elsewhere in the universe, and considering the advances in the search for exoplanets, it is difficult to rule out the possibility that alien beings exist beyond our planet, although we do not yet have conclusive proof. Discoveries and evidence suggest that the existence of extraterrestrial life is a fascinating possibility given the size of the visible universe. What about the multiverse? Let me tell you, the options are almost limitless. According to some interpretations of quantum physics, the act of observation can cause a quantum system to collapse into a single state. However, in the many worlds interpretation, the act of observation simply causes the system to split into multiple states, each representing a different outcome. The multiverse, also known as the many worlds interpretation, is a theoretical idea in physics and philosophy that suggests the existence of multiple parallel universes or dimensions beyond our own. This idea is primarily discussed in the context of quantum physics, which deals with the behavior of tiny particles like atoms and subatomic particles. Given that we do not yet know what exists outside of our universe, the possibility of the existence of a multiverse remains as valid as the well-known Schrödinger's thought experiment or the nature of darkness. It is crucial to note that the idea of the multiverse is still very speculative and has not yet been supported by conclusive evidence, making it difficult to say with certainty whether it is a valid concept or not. Some scientists and philosophers find the idea of the multiverse intriguing and potentially useful in explaining certain phenomena, while others are skeptical of its validity. It is an idea that inspires interest and contemplation, but more study and proof are needed to validate if the dark flow phenomena is real. The query is intricate and presents a fascinating problem. The idea of dark flow was first proposed in 2008 as a potential explanation for the finding that certain galaxy clusters appear to move more quickly than would be predicted given the distribution of matter in the universe. It postulates that these galaxy clusters may be pulled in a particular direction by some type of dark matter or dark energy, but the existence of dark flow is still debatable and has not yet been acknowledged by the scientific community as a whole. More research and evidence are required to fully comprehend this fascinating phenomenon. Some studies have suggested that dark flow may exist and that it could be caused by a massive structure in the universe that attracts galaxy clusters. Other studies, however, have failed to confirm the existence of dark flow and have suggested that the observed motion of galaxy clusters could be the result of other factors, such as systematic errors in the detected ones. Others have suggested that while dark flow may exist, we cannot say with certainty that it is present outside the observable universe. Please share your thoughts in the comments section, don't forget to like and subscribe, and we'll see you in the next video. The cosmic light horizon, the farthest out from which light has had time to reach us since the Big Bang, defines the boundary of the visible cosmos. This is a limit to human observation, not the universe's actual boundary. Depending on the universe's general form and structure, which cosmologists are now studying in the cosmic microwave background, the cosmos may continue endlessly or may curve back on itself beyond this horizon. CMB, a faint glow left over from the Big Bang, marks the farthest back in time we can observe using electromagnetic radiation. It offers a snapshot of the universe when it was only 380,000 years old and remains a crucial piece of evidence for the Big Bang theory. Eventually, if humanity overcomes the massive technological challenges, we may attempt interstellar travel. Concepts like fusion, propulsion, antimatter drives, or the Breakthrough Starshot initiative, which aims to send small spacecraft to nearby star systems using light sails propelled by powerful lasers, represent the early seeds of this dream. Even more speculative technologies such as warp drives or Einstein-Rosen bridges wormholes are being explored in theoretical physics. While many of these remain in the realm of science fiction, they reflect humanity's innate desire to reach beyond the stars and find our place in the universe. While we marvel at what we've discovered within the observable universe, we must remain aware of how much lies beyond our current understanding. Every new discovery, whether it's the discovery of water vapor on an exoplanet or a far-off galaxy photographed by the James Webb Space Telescope, raises new questions and opportunities. What will happen to space exploration given the speed at which technology is developing? Both commercial businesses and space organizations are expanding the frontiers of NASA exploration. Others, like ESA SpaceX, are funding lunar missions. Mars and Beyond the Artemis program, for example, intends to send people back to the moon and establish a long-term presence there as a prelude to expeditions to deeper space. The long-held ambition of engineers and dreamers to colonize Mars is becoming closer to reality. In the event that future human trips are successful, robotic missions will continue to gather data, test landing technologies, and look for evidence of ancient life in order to construct the first permanent settlements on another planet. International cooperation becomes not just advantageous but also necessary for programs like the International Space Station as the scale and complexity of space research increase. The James Webb Space Telescope and future lunar outposts serve as examples of what can be accomplished when nations pool their resources and expertise. These partnerships increase scientific yields and spread the high expenses and hazards associated with space travel. Philosophical and ethical issues. As mankind expands its reach into the universe, it must confront significant philosophical and ethical issues about the possibility of colonizing other worlds. How can we safeguard ecosystems in other countries? How would discovering alien life, even microbiological life, require us to reevaluate our role in the cosmos, and what obligations do we have as stewards of the Earth and perhaps ambassadors to other worlds? How would this impact religion? At its core, space exploration is about more than just science and technology. It's a reflection of the human spirit, which is inquisitive, motivated, and unwavering in its pursuit of knowledge. We explore because we long to comprehend our origins, our place in the cosmos, and the future that lies ahead. Philosophy and our understanding of life itself are the ultimate questions why we explore. Somewhere something incredible is waiting to be known, Carl Schon once said. Whether we are planning the first steps on Mars or looking into the depths of space to study galaxies billions of light years away, one reality stays the same. The adventure has only just started. That emotion continues to inspire and lead scientists, engineers, and visionaries worldwide.